This is a brand new way of an equation looking like for us to be able to graph it, and yet we have dealt with equations that look like this before. We saw them in the first part of this particular unit, when I would give you something that looks like that, and I would just say to simplify it. So the very first thing we're going to do in order to be able to graph this is also to simplify it. We're going to bring back those old skills. So in order to simplify this, the first thing we need to do is we need to look and see what we can factor. And you notice the bottom of this fraction does factor. So what are the two numbers then that add to 2 and multiply to negative 15? 5 and negative 3. So we can factor it then. And then we factor it because that's then what's going to allow us to actually make this look a lot cleaner and, in so doing, doable. Because as I take a look at my current factored form now, notice what appears in both the top and the bottom. That x minus 3 is in both the top and bottom, so they're going to cancel out. Now, when I cancel those out, what is left on the top of this fraction? 1, absolutely. And so it's 1 over x plus 5. Then, having done that, we do have one other step that we got into about how do we actually write our final simplified answer. Because you remember we had to include restrictions. Well, we're going to have to include the restrictions here as well. So remember that the restrictions are saying what x cannot equal. And it was determined by what would make the denominator of the fraction equal 0. So what would make the denominator equal 0 in this problem? This part would give us negative 5, absolutely. And this part would give us 3. And so we write that fully simplified form, including the restrictions, first. And then we can actually start looking at graphing it. Because you notice the beautiful thing about the way this one worked out. Y equals 1 over x plus 5. We can graph that. We know how to do that one. So let's go and start graphing it. First of all, where are the asymptotes going to be? The horizontal asymptote first. The horizontal asymptote changes based on how far it's been moved up or down. Has this one been moved up or down? No. Because there's no number that's being added or subtracted after the fraction. So our horizontal asymptote is actually going to be at 0. The vertical asymptote, though, it has moved because the plus 5. What's the plus 5 do to it? It moves it left 5. And so, in order to make the graph, we start by drawing in our two asymptotes. Go ahead and draw those in if you haven't yet. And then once you've drawn in the asymptotes, go ahead and draw in the graph then. So we're graphing 1 over x plus 5. There's no stretch or anything. So for instance, the first point's at 1, 1 from the asymptotes. Remember, everything's relative to the asymptotes here. And keep plotting the points just like you did for the parent function of 1 over x for this one. And so this then is the graph that you should come out with here. Now for this graph, you'll notice that it is the same parent function of y equals 1 over x with a transformation of being shifted left 5. But there's one other thing that we have to account for here. There is one change that we have to do because we started with this whole thing at the start instead of just starting with this. It actually comes down to the restrictions that we identified. So notice we know that x cannot equal negative 5. Well, that's obvious, I hope, because that's where the asymptote is. We've dealt with that quite a bit. But the 3, how do we deal with the 3? Because clearly, as you take a look at this graph, there's not an asymptote at 3. So how do we account for it? Well, what we're going to do is where the graph hits x equals 3, we're actually going to erase a little piece of the graph there and replace it with an open circle. And so I then put an open circle here on the graph at x equals 3, because remember x cannot equal 3, to show that that one point is excluded from the graph. And then once we see that, then we can get into some of the other little details about this function. Let's take a look at the domain and range. Now, for the domain, first of all, is domain X or Y? X. So we know the domain here is going to be X cannot equal something. Now, just based on what we simplified it down to and where we can see the asymptote, we know that X cannot equal -5, because that's where the asymptote is. But we also have to account for the fact that X cannot equal this value, the hole in the graph. And so X can also not equal 3. Now, what do you notice about our domain here? You should have seen that someplace else on your paper earlier, right? It's the restrictions. Yep. The domain is the restrictions, and restrictions are domain. When we were talking about restrictions before, technically what we're doing is we're giving the restrictions on the domain. That's just a longer way to say it. All right, now we need to take a look at the range. For the range, what can y not equal? Well, 0 certainly, because we can have an asymptote at 0. But now things get a little bit trickier, because there is one other. Because our hole here in our graph, it has a y value at that hole as well. And so we need to figure out what the y coordinate is of that point. Now, in order to do that, the way that we do it is we take our simplified equation that we got earlier, y equals 1 over x plus 5, and we plug that x value in. So I'm going to take this x value of 3, and I'm going to plug it in for x. So that gives me y equals 1 over 3 plus 5, which then is 1 over 8. So that tells me what the y coordinate is of that point that's being excluded. So I also include that as my other restriction.